Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion of IAL Physics Unit 1, November paper 2023. If you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. In Proflan YouTube channel, we do matters, physics, and math. So if you are taking Cambridge Edexcel, A-Levels, AS, and IGCSE, this is the place for you. We're going to have a discussion of some of the questions of that are asked in various sections of this paper, and we're going to have a discussion on how you're supposed to approach each of the questions step by step in order to understand how you can be able to earn your marks. We're going to look at the first question that was tested in the first section, whereby we are told that here are different quantities which can be classified into scalar and vector quantities, and then we were supposed to identify which row of the table that is correctly marked with scalar and vector quantities. Something that you need to appreciate at the first place and the beginning of this is that scalar quantities have only size or magnitude, meaning that scalar quantities can be described only in terms of size. They don't have direction. Vector quantities have both size and direction. So energy is a scalar quantity, momentum is a vector quantity, and that qualified that answer to be A. We have to state the SI unit of momentum. That is, remember, momentum is mass times velocity. So which will mean that this unit, kilogram meter per second, is the correct unit. Which of the following could be used to describe the elastic limit of a material? Elastic limit, remember, is the limit above which an object undergoes plastic deformation. And in that way, stress above which the material will be deformed even when the stress is removed. So that is the plastic deformation. And for number 3, the correct answer is B. Now we need to look at motion graphs. The first graph is displacement time graph. This is showing the object is stationary. We have the second graph. This is an object that's moving from rest. Yeah, the object is moving from the initial position, and that is moving at a constant velocity. But if we are talking about a ball that is falling through gravity, velocity is not going to be constant. The object will be accelerating down. So the correct answer is C, which indicates that the object is increasing from 0 and the object is accelerating. This is not correct because it's indicating an object with a decreasing velocity. Moving to number 5, we are told that an helicopter moves vertically upwards with an increasing speed, so meaning it's accelerating upwards. Which of the following describe the increase in gravitational potential energy? Remember, increase in gravitational potential energy is like the work done to work against the force of gravity. So we can say the work done by a helicopter against the force of gravity is what we call the increase in the gravitational force. So the correct answer is C. Moving to number 6, the kinetic energy of object is doubled. If we are told that an object moves with a velocity v, the kinetic energy of the object is doubled. Which of the following is an expression for the new velocity of the object? Remember, kinetic energy is equals to a half mv squared. So we can say the initial kinetic energy is a half mv squared. Now kinetic energy 2 is going to be 2 times the kinetic energy 1, because we are told kinetic energy is doubled. So if it's doubled, then the new kinetic energy will be 2 times the initial kinetic energy. So meaning we can be able to substitute K1 with a half mv squared, because we had said that. So if you multiply here, you see these 2 and 2 will cancel out. We have mv squared, which means that K kinetic energy final now, after the kinetic energy has been doubled, can be written as what? Mv squared. So but remember, kinetic energy can be given now with the new velocity which we need. The new velocity, we can call it V2, right? We can be able to write it from the initial equation that kinetic energy is a half mv squared, but this is the new velocity now. But already we had said kinetic energy can be written as what? Mv squared with the new doubled. So we can be able to equate this equation together with this equation we were having here. M and M is going to cancel out. And finally, if you make V2 the subject, we're going to get is root 2 V, which is option A. A power station provides an electrical output power of 2.1 gigawatts. The power station transfers thermal energy to the surroundings, so meaning there's some energy that is wasted. And remember, efficiency is useful output over total input. But the total input is going to be 2.1 plus 3.4. Then the useful was the one that was the output 2.1 gigawatts. So if we divide, the option is X. A student applies a tensile force to a metal wire of length X and diameter D, and the length of the wire increased by delta X. The student applied the same force to the second wire. Remember, the tensile force now is the same, and made the same material to we have the second wire made of the same material, meaning the Young's modulus is the same, and the length of the second wire increased by 2 delta X. Which row of the table could show the length of the diameter? The length and diameter of the second wire. So something you need to realize is that long material stretches easily, and materials which have a small diameter stretches easily. So we are going to use this relation whereby I used Young's modulus, I used stress and strain, I derived this equation, and I was able to come to a conclusion that the length should be a half of X and the diameter will be a half of D. And the answer is A. A box of weight W is suspended in equilibrium from the support by 2 ropes. The tension in the ropes is T1 and T2. And then now if we have we have 3 forces. Since the object is at equilibrium, then the 3 forces combined is going to form a closed triangle. And then if the object is at equilibrium, it means the resultant force is going to be 0. So meaning the sum of all the forces, T1 plus T2 plus T3, is going to give us a resultant force which is 0 because the object is at equilibrium. If you are new to Proflan YouTube channel, consider subscribing so that anytime we're going to upload another tutorial, you'll be notified. We have also a box which is pulled at an angle like this. And if work is done to move this box a distance of 5 meters along the ground, then we cannot be able to use this force the way it is in order to calculate the work done. Remember, work is done when a force is applied to move an object in the direction of the force. So this force is acting at an angle, so which means that if we want to calculate the work done to move it 5 meters along the ground, we have to work out the horizontal component of this force so that we can say this is 30 cos 40. Then work done is force times distance, and our distance is d cos theta. And when we substitute, we are going to get our answer as 115 newtons as the answer in that case. We have a photograph that shows a rocket, and this rocket is launched vertically, and then the rocket engine gives a total upward thrust of 7.3 times 10 raised to the power 7. We are supposed to calculate the initial acceleration of the rocket, but the mass of the rocket is 5.0 times 10 raised to the power 6 kilograms. So something that you need to realize that when the rocket is actually moving upwards, we have an upward force which is the forward thrust, and there will be a downward force which is the weight of the rocket. But for us to work out the resultant force, it means we're going to use the formula for weight. We get the weight, and then we work out the resultant force by subtracting the upward minus the weight which is acting downward, and that gives us 2.395 times 10 raised to the power 7 newtons as the resultant force. Then we're going to apply the Newton's second law, and we're going to say force equals to mass times acceleration. Since we are working out the initial acceleration of the rocket, we are going to rearrange this formula that we have here so that we can make A the subject of the formula. And working it out, we're going to get our answer as 4.7 times 10, 4.79 meter per second square. Now, the question is, give a reason why the acceleration will increase as the rocket rises. As the rocket rises, remember, it will be using fuel, and therefore the overall mass of the rocket will be decreasing. And for that reason, the rocket will accelerate. A glider A and B and air track has the same mass B, and A and B are initially stationary when A was pulled gently towards B as shown. State the principle of conservation of linear momentum. This is an area that you really need to understand how to state the law of conservation of linear momentum, and we say that total momentum before collision is equal to the total momentum after collision, provided no external force acts. So we are also supposed to proceed to the next part. Part 2 will be coming soon. You can also check it in the description down below. I'm going to add part 2 of this video. If you got value from this video, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. See you in the next video.